So the experiment itself is comparing biochar to peat in potting media. And so standard potting media in the Willamette Valley is usually made with something like 50% Doug fir bark, a bit of perlite, maybe 15%, and then peat, something between 15 to 30%. And the peat really serves to hold moisture and nutrients. The problem with peat is that it's mined in Canada. It is essentially mined by draining peat bogs in Canada, taking those bogs and shipping them down here to use in potting media. And peat tends to be the most expensive component of a potting mix. I mean, if you think about the three components that I mentioned, perlite, Doug fir, and peat, Doug fir is all over the Willamette Valley. There's plenty of logging operations. So that tends to be Doug fir bark. There's a lot of that available. It's very cheap. The perlite is actually produced, some of that is produced here in Oregon from volcanic rock. Sometimes pumice is used also. So that's pretty cheap too, and the peat really is the expensive component of the mixture. So minimizing the amount of that peat that you're using is pretty important as well. So the idea here is maybe we can use a locally available resource to substitute in for peat. And I've been studying biochar for a couple years now, and it has an incredible ability to hold water. That was what my research at OSU was about. And so it has a really amazing ability to hold water, and that comes from the porosity of the material. And now biochar itself is something like charcoal, and it's made by a process called pyrolysis. And during this pyrolysis process, you take biomass and you heat it in the absence of oxygen. So we get our char from John Middema of a company called Biological Carbon, and that's out of Philomath, Oregon. And he built from scratch a biochar retort that's something like 15 or 20 feet tall, and I think it produces about 500 gallons of char at a time. It's a really cool machine. And during that process, you get a whole lot of properties in the material that are really beneficial for a lot of things. The most important property that you get is an incredible amount of surface area and porosity. Some of the chars that we work with have something on the order of 300 meters squared per gram of surface area. And a gram of the material, you know, it's about the size of a golf ball. So we're talking about 300 meters squared of surface area in the size of a golf ball. And that allows it to hold incredible amounts of water, nutrients, and we think biochar is a great application in the state of Oregon because we have all this biomass. We have a whole lot of timber industry in Oregon. So there's a lot of biomass available. And so we've been looking at different ways to use this sort of high-value products, applications for biochar. And I've looked at things like stormwater filtration, water filtration, a lot of things having to do with water. We found that high-temperature chars have the most surface area, the most porosity. They're sort of the best for holding water, holding nutrients, all these things that we really want our chars to do. So we've made this char at 600 degrees Celsius, and it comes out as little, bits of charcoal. So we wanted to see how much processing was sort of needed from our bulk char that I had in a big drum at home to what we use in our mixes here to see how it affects the water holding and growth of these marigolds. And now we chose marigolds just mainly because they're a very easy plant to grow. They respond to a lot of environmental conditions in potting media, so they tend to be used in different potting media trials to test media rather than to test plants or nutrients. So we used it as a sort of an indicator species. During the harvesting process, we'll be clipping the tops of these off, and then we'll be drying them, and then the same goes for the roots. We're going to be washing all of the soil off the roots, trying to get every last bit without losing any of the fine roots. And then we'll be clipping those off as well and putting them in a drying oven for, I believe we'll put them in for about a week plant. And we'll do roots and shoots is what they typically call them. And we really want to see how these char treatments compare with peat. I mean, we're hoping to see that they're pretty similar, that this char can be a good substitute for peat, especially as there are more and more char producers in the area.